Hello everyone, my name is Filip and I'm a Revuto Orphan Scout, and today I will be talking to you about Haskell. Now this is maybe a bit more technical than we are used to, but I'm going to do my best to give a high-level overview of what Haskell is and how it is used and implemented in Cardano. Okay. So first of all, what is Haskell? Haskell is a programming language, a Turing-complete programming language. Now, Turing-complete is just a fancy way of saying that whatever any programming language can do, whatever any computer can do, can be programmed in Haskell. So it's anything that is computable can be computed using Haskell. Haskell is statically typed. Statically typed basically means that the types of all the variables need to be decided at compile time. So this is just an additional level of assurance that maybe some programmer mistakes while identifying types can be avoided even before we start testing the program. So it's just an additional security safety check. It is purely functional. Purely functional is a concept that is a bit difficult to explain, but basically Haskell uses functions and just statements that cannot mutate variables. And lambda functions are let's say the assembly, the low-level language of Haskell. This is different than maybe imperative languages that are more state-based and that just manipulate the state of the program as we iterate through the program. And it is lazy evaluated. What does that mean? Lazy evaluated means that every statement is evaluated if and only if it's absolutely necessary, which, if programmed correctly, can enable some performance benefits because you don't overload, let's say, the processor, the memory with unnecessary calculations, unnecessary computations, right? Okay. So why did Cardano team decided to use Haskell? So first of all, to understand, Haskell is used as a language to develop the Cardano node software. So the whole consensus layer of the protocol, staking and communication between different nodes is implemented in Haskell, right? But the second layer, the applicative layer, is not necessarily implemented in Haskell. We'll go over that a bit later. So as you know, the methodology of Cardano development is always scientific papers first. So everything needs to be scientifically proven that it can actually be done, and then and only then will it be implemented through code in a real-world environment, right? So the first step is writing the scientific paper, describing the mathematical methods and proving and peer reviewing and all of that. And then what is required is to take that paper and kind of translate it into code, which is by no means a simple task, right? And Haskell is very adept because of its functional nature and also because of the statically typed feature and type inference. It's very natural to implement mathematical ideas into real-life code, right? So that was kind of the idea. Okay, I can basically use the proof that is already in a paper, and I can more easier than some other languages, I can implement it in code and I can test it out. Again, we have this high assurance of safety. As you know, cryptocurrencies are the value at stake is very high. We need to be very certain that the code that is deployed is actually correct, doesn't have bugs. And Haskell consists a mix of functional programming, the type system, and it has a large set of tools that really force a developer to think about the code and the consequences that that code will have. So it is designed as a programming language to decrease the possibility of bugs as much as possible. There are other languages that do that, and there are languages which are more scientific. But Haskell was, let's say, a balance between an understandable, human understandable programming language and a language that is scientific enough to implement the scientific papers. And of course, it can also be viewed and used. The code written in Haskell can be a reference code for other languages, right? It can be a mid-step between a scientific paper and, let's say, Rust code. Rust is another programming language, is also popular in the blockchain community, in the blockchain ecosystem. So it's much easier for a Rust developer to understand the Haskell implementation of the code than the scientific paper that determined that code. So we can see Haskell as, let's say, a middle step between the Rust implementation and the scientific paper. So Haskell is kind of let's call it a niche language. It's not really popular as some of the most popular languages like Python, C++, and other things. So there are some usual criticisms about why Cardano chose to develop their reference implementation in Haskell. So these are some of the cons, and I would like to, tackle them. It's the most common comment is it's difficult to learn. I would agree, as someone who is learning Haskell, I would say that it's not as easy to learn as maybe some other languages. But I would not say that it's so difficult that it cannot be, it cannot be taught. This is nonsense. It does require a different way of thinking than what we call normal programming. But once these concepts kind of settle in your mind, it becomes natural and it becomes just another programming language. Because of this difficult to learn reputation, there are not so many developers on the market, Haskell developers, compared to other programming languages. Because there is not so many developers out there, the cost of development is higher because fewer devs, of course, increase the prices. This is true, but the benefit for Cardano is that the average, let's say, Haskell developer is usually, not always, but usually scientifically inclined already. So this developer is much more likely to understand and implement the scientific paper because of the understanding of the language and the underlying math under it. So that's kind of a benefit. It's difficult to find a developer, let's say, but usually when you find a dev, he or she knows exactly what you need. And one of the criticisms that I see and I simply disagree with is the lack of libraries in Haskell, like the lack of supporting tooling, which I just think I know it's not true. There are plenty of libraries, plenty of implementations, plenty of examples. Haskell Foundation is a non-profit organization that takes care of the libraries, maintains them, upgrades them, and so on and so on. Even IOG, as one of the founding entities of Cardano, financed, and I believe still finances, a bit of Haskell Foundation to maintain and upgrade the code and the documentation about the language itself. So I would like to share some, final thoughts about this. I talked about the safety of the Haskell programming language, and it is inherently safer, I would say, than other languages. But this does not mean that it is perfect. This does not mean that code written in Haskell cannot have bugs. This is by, we cannot talk about it like that. We always need to be careful because there are always possibilities for bugs, and what is much more dangerous, an intentional backdoor left by a developer for some bad purposes, let's say. So still, code auditing is very important. Extensive use of tooling in Haskell is very important. These tools exist, but of course, it's on the developer to choose which tools to use and how much will they be used and how thoroughly will the code be tested. Second thing I would like to say is, again, Haskell is used for the node implementation of Cardano. So we can be pretty certain that the basic layer of Cardano, stake pool operations, basic transaction sending, is secure and safe. But this does not mean that applicative layer of Cardano, because when you have websites that connect to DEXs, that connect to smart contracts, etc., these things are developed in other languages with other methodologies, with other methods that can open a lot of backdoors and potential malpractices of the software. So it's important to understand that just because the node is developed in Haskell, any Cardano dApp or implementation does not carry the same safety. So my point is, in the end, just please be careful what software you use. Be careful to try to see if the team that has developed it has some audit. Is the code public? Is the code tested before? Try to be careful with these things, because there will definitely come a time when some people will abuse the philosophy of Haskell and for marketing purposes, and maybe provide some bad intentions in the way. So I hope you learned something new. Please, if you have any comments, if you have any questions, make sure to ask in the comment section, and we will do our best to answer them. Thank you very much.